Miss Howard's Chemistry, Unit 6, Chemical Bonding, Lewis dot structures, naming compounds, and writing formulas. And we still have those 5 teaks that the state of Texas says you guys are going to have to do. Writing compounds, naming compounds, understanding the metallic nature of bonding, and predicting molecular geometry. And molecular geometry is Roman numeral number 4 on here. Okay, in order to figure out the shape of the molecule, we use something called the VSEPR theory. VSEPR stands for valence shell electron pair repulsion theory. And pretty much what it means is, think about this in your brain, like charges repel, right? We can't get into the nucleus to mess with the positive charges, so we're just focused on the electrons. And the electrons repel each other. They're going to push away from each other. They're going to organize themselves and create the shape of the molecule by getting as far apart from each other as they can. Okay, so it's a model for determining molecular geometry, which relies on one simple principle: electrons repel each other. In every molecular structure, the electron pairs on the central atom. We're just focused on the middle atom there. Whether it's shared, bonded, or unshared, or whether the electrons are shared in the bond or unshared. If they're unshared, we call them lone pairs of electrons. They will distribute or spread themselves around the central atom so as to be as far apart as possible. So, electrons want to get as far apart as possible from each other. But we're only looking at the electrons on the central atom. Now, it's important to keep in mind again that it's the electron pairs on the central atom that are doing the repelling and generating the shape, not any of the other electrons on the atoms that are attached to the center. Okay, how to find geometry. Draw the Lewis structure for the model. Okay, that's where we put the little dots in everywhere. Count the number of atoms that are stuck to it, and don't count the number of bonds. Count the number of atoms that are stuck to the middle. So if we have H2O, O is in the middle, and we have 2 atoms that are bonded to it or stuck to it. Count the lone pairs of electrons that are stuck to it. Don't count the number of bonds. Go to the central atom. How many lone pairs of electrons? And for water, there are 2 lone pairs of electrons on the oxygen atom. So we drew the Lewis structure with all the dots. There were 2 atoms bonded to the central atom, and there were 2 lone pairs of electrons. And then what we do is there's a chart on page 186 in your book. Oh, I guess I didn't put it on here. There's a chart that it tells us, and it's a chart that says if it's got 2 atoms and 2 lone pairs of electrons, its shape is bent. And when we say it's bent, it means that the lone pairs of electrons, they're not shared, so they've got more repulsion, and they push apart so far from each other that they push the hydrogen pieces down towards each other. So hydrogen or oxygen form a little bit of an angle here. Again, it's only going to be the central atom. Here's the chart that was on page whatever I just said a minute ago. So we said there were 2 atoms bonded to the oxygen. So we find in our list we've got 2, 2. There are 3 of them that have a 2 section there. But it also had 2 lone pairs of electrons. And you see down at the very bottom, 2 and 2. And what we have is bent or angular. And oh, there's water as an example there. The state of Texas says you only have to know 3 of them. So you have to know linear, which means it's just in a straight line. You have to know trigonal planar, and if you look at trigonal planar, you notice it's got 1 atom in the middle and 3 trigonal, 3 atoms coming off of it. And then it says you have to know tetrahedral. Tetrahedral, look at the example for tetrahedral. It's got 1 carbon atom in the middle and then 4 legs coming off of it. Tetra, 4. So they're not pushing you too hard on figuring out what these things are. So linear is just going to be in a straight line. Trigonal, it's got 3 legs, 1 central atom, 3 legs on it. Tetrahedral, 1 central atom, 4 legs on it. And then I'm going to throw in 1 more because it's water. And you need to know that water has a bent or angular structure. Okay, what about naming and writing the formulas. Well, I haven't made the other videos on naming and writing formulas just yet, but there's a great one on YouTube, and if you look up Bozeman, Bozeman, biology, he's a teacher from Montana. He's fantastic. He was the Montana Teacher of the Year in 2011. Great teacher, but he's got a little short video on naming compounds. So Bozeman Biology on YouTube. He's a good teacher. It'll really be a help, and you can use that until I get mine. Also, your notes packet has a flow chart in it, and if you will use that flow chart to name your compounds, after using it a few times, you won't really need it so much because I wrote it, so it's that good. If you lost yours or you can't find it, go to mshoward.com and find chemistry and find the unit on bonding and naming, and there's another copy of the flowchart that's on there. That's the end of this set of notes until I make one for the naming and the writing formulas.